Hi students, this time we will discuss about a new topic, supernode analysis. In the previous class we have discussed about node analysis and next is the supernode analysis, and here is the supernode analysis. If there is a voltage source between two adjacent nodes, it is slightly difficult to apply nodal analysis, and one way to overcome this difficulty is to apply supernode technique. We know that whenever a circuit has a larger number of current sources, it is better to apply nodal analysis compared to mesh analysis. And suppose if the circuit containing voltage source and current source, and we are applying nodal analysis, and if that voltage source is in between two branches, adjacent nodes, then it will be very difficult to apply node analysis. So we will use supernode technique in that case. Okay, so similarly we have studied about a super mesh analysis. Okay, in the case of mesh analysis, whenever a current source appears between two adjacent branches, it will be difficult for mesh analysis to solve the circuit. So in that case we will use super mesh analysis. Similarly, in the case of node analysis, if there is a voltage source between two adjacent nodes, then it will be very difficult to apply node analysis. So we will use super node analysis. Okay, so in this method, the two adjacent nodes that are connected by a voltage source are reduced to a single node, and then the equations are formed by applying Kirchhoff's current law. And here in the similar as that of the super mesh analysis, in that case in super mesh analysis we will neglect the branch that is connected the voltage source, and we will apply mesh analysis. Okay, in this case in node analysis, so in super node analysis we will the two adjacent nodes that are connected by voltage source are reduced to single node, and then the equations are formed by applying Kirchhoff's current law. So here is the example, and here I have given a circuit that containing a current source I, resistors R1, R2, R3, R4, R5, and voltage source Vy and Vx. Vx is connected between, you can see Vx is connected between node 2 and node 3. Other nodes are 1, 2, 3 are nodes, and fourth node is the reference node. And voltage source Vx is connected between two nodes, okay, adjacent nodes. So in this case, node analysis will be very difficult. So we have to use super node analysis. So first of all, we have to understand the super node analysis. Before that, we know that we can apply current law, Kirchhoff's current law to the node 1. Okay, so we can redraw the circuit for node 1 as we can see it in the lowest corner, that is node 1 is marked and its voltage is V1, and R1 is connected to node 1, R2 is also connected to node 1, and a current source is also connected to node 1, and all the currents are leaving the node V1 except the current source. So we can write the equation for KCL as I1 will be equal to IR1 plus IR2. So we can write the equation as I1 equal to V1 by R1 plus V1 minus V2 by R2, and the equation how it comes I have discussed in the node analysis section. Okay, I think it is not necessary to explain those steps again. Okay, so I equal to V1 by R1 plus V1 minus V2 by R2. Why V1 minus V2 is taking? Because R2 is connected between V1 and V2, so we have to use differential voltages. Okay, that's all about the first node. And next we have to consider second node, but you know that there is a voltage source, so we are combining these two nodes, and we will draw the super node, and we have to apply node analysis to that super node. So for drawing the super node, we have to neglect the branch which containing the voltage source, that Vx is removed there. Okay, Vx is removed. We will remove the Vx, and we will draw the rest of the part of the circuit with the node V2 and V3, and all other components connected to V2 and V3 will be there in the super node. Okay, so what all components will be there? There will be V2 node, V3 node, and to V2 node there will be resistor R2 and R3 will be connecting, and to V3 node resistors R4, R5 and voltage source Vy will be connecting. Okay, that is will form the super node, and the super node will be look like this. So here the super node, I have drawn the super node, V2 and V3 are there, and the voltage source is not there, it is removed, and to V2 to the node V2, R2 is connecting and R3 is connecting, and you know that R2 is connected to the other node V1, so V1 voltage is marked there, and to V3 resistors R4 is connected, and R4 is connected to the voltage source Vy, so it is marked there, and resistor R5 is connected to node V3. This is all about that super node, and we can apply Kirchhoff's current law to this super node. Okay, so what will be the equation? Kirchhoff's current law. Here it is written that voltage source Vx is present between node 2 and node 3. So it is difficult to find the current. The supernode technique is used in this case. Accordingly, we can write the combined equation for node 2 and node 3. And here we are neglecting the voltage source Vx, and we can write the node equations by using Kirchhoff's current law. So for the node V2, we can write V2 minus V1 by R2 plus V2 by R3 plus V3 minus Vy by R4 plus V3 by R5 will be equal to 0. See, you can, first of all, you can mark the current. All the currents will be leaving the nodes. So there are no other current source, external current source connected to node 2 and node 3. So we can write that algebraic sum of the currents will be leaving the algebraic sum of current leaving the nodes will be equal to 0. So starting from the point node, starting from the V2, we can write the node equation as you know that R2 is connected to V2, and the current through R2 will be equal to V2 minus V1 by R2. Okay, there is no confusion in that equation. Okay, and also the current through R3 will be equal to V2 by R3. It's clear. And next, the current through R4 is V3 minus Vy by R4. Why V3 minus Vy? Because we are assuming that V3 is at a higher potential than that of Vy. So we are taking the differential voltage as V3 minus Vy. And the current through the R4 will be V3 minus Vy divided by R4. That is simple Ohm's law. And next is the current through R5, that is V3 by R5. And a sum of every terms will be equal to 0. So that is why we have written the equation number 2. And also from the first figure, here is the first figure, we have applied node equation for V1 and super node for V2 and V3. And we have three variables, V1, V2 and V3, but we have now two equations, and we have to form the third equation also. And we can see from the figure that there is a voltage source Vx that is removed in the second node analysis, in the super node analysis, and we can write the equation for Vx as V2 minus V3 will be equal to Vx. Okay, so we will write the third equation as V2 minus V3 will be equal to Vx. That is the third equation. So we got three equations and three variables, V1, V2, V3, and we can solve these three equations by Cramer's rule. Okay, this is how we can solve the problem or a circuit if it contains a voltage source in between two nodes. Okay, so this is a super node technique, and you can solve a problem and you will get the idea more clear. So this is the problem, first problem 1. Determine the current in the 5 ohm resistor for the circuit shown in the figure. So we have to find out the current in the 5 ohm resistor. See the circuit diagram. You can see it contains a 10 ampere source. Resistors are 3 ohm, 2 ohm, 1 ohm, 5 ohm, 2 ohm, and there is a voltage source 10 volt, and there is another voltage source 20 volt. You can see that the 20 volt voltage source is connected between V2 and V3. So at that point you should remember that you should use super node technique, because 20 volt battery is connected between node 2 and 3. So you have to use super node technique. Okay, and you are asked to find out the current through 5 ohm resistor. Once you got the value of V3, you will get the current through the 5 ohm resistor. So first of all, let us start the problem. So let us start solving problem. First of all, we have to draw node 1. There are 3 nodes, it is marked in the question itself. So for node V1, you can draw the diagram V1. What all are the branches connected to node 1? 10 ampere source, 3 ohm and 2 ohm. Okay, so next, in the next step we can mark the branch currents. Okay, 10 ampere current is flowing into the node, and others are 3 ohm and 2 ohm resistor, so the current marking will be out of the node. Okay, the other two currents are flowing out of the node, so we can mark it as I2 and I3. That is, current through 2 ohm is I2 and current through 3 ohm is I3. So what is the node equation? At node 1 we can apply Kirchhoff's current law, that is algebraic sum of current meeting at a junction will be equal to 0, or the sum of incoming current is equal to sum of outgoing current. So 10 is incoming current, I2 and I3 are outgoing current, so 10 will be equal to I2 plus I3, and 10 equal to I3 is V1 by 3 and I2 is V1 minus V2 by 2. Why V1 minus V2 comes? Because 2 ohm resistor is connected between two nodes V1 and V2. So we are taking the current through 2 ohm will be equal to V1 minus V2 divided by 2. And we can rearrange this equation and we will get the equation as 0.83 V1 minus 0.5 V2 will be equal to 10. That is equation number 1. So we have considered node V1. Next we have to consider node V2. Before that we can see that a voltage source is connected between node V2 and V3. So we have to consider these nodes together by neglecting 20 volt battery. So it will form a super node, and we can write the equation for super node. So at node 2 and 3 super node equation is, first of all we have to draw the diagram of that super node, and V2 2 ohm is connected and 1 ohm is connected, and at V3 5 ohm 2 ohm is connected, and there is also 10 volt battery, and we will neglect 20 volt. So this is the super node diagram, and we will mark the currents are leaving the nodes. Okay, so we can write the algebraic sum of current will be equal to 0. Since there is no current sources connected to these nodes, the algebraic sum of currents will be 0. Okay, so we can, starting from the node V2, we can write the equation as V2 minus V1 divided by 2 plus V2 divided by 1 plus V3 minus 10 divided by 5 plus V3 divided by 2 equal to 0. You know how to write these equations. Okay, once a branch is connected between two nodes, we have to consider differential voltage of that nodes. Okay, and by rearranging the equation we will get a minus 0.5 V1 plus 3 by 2 V2 plus 7 by 10 V3 minus 10 by 2 equal to 0. So we can write minus 0.5 V1 plus 1.5 V2 plus 0.7 V3 is equal to 2. That is the second equation. So first we got an equation, second we got an equation. But we know that from 1 and 2 there are 3 variables, V1, V2, V3, but we have 2 equations. So we are in the necessary, we need one more equation to solve for unknown variables. So what will be that equation? We know that in the analysis we have neglected the 20 volt battery, but when we are considering that 20 volt battery, what is the, we can write the equation for that 20 volt battery as V2 minus V3 will be equal to 20. Okay, since 20 volt is connected between V2 and V3, we can write it as V2 minus V3 will be equal to 20 volt. Okay, the potential difference between the two terminals will be equal to 20 volt. That is its meaning. Okay, that is 20 volt battery, its positive terminal is connected to V2 and negative terminal is connected to V3. That means the potential difference between the 2 points V2 and V3 will be equal to 20 volt. So V2 minus V3 equal to 20 volt. That is its explanation. Okay, so we have got 3 equations, 1, 2 and 3, and we know that there are 3 equations and 3 variables, and we can solve for V1, V2 and V3 by using Cramer's rule, and we have written the 3 equations as 1, 2, 3. Okay, and how can we get the how can we apply Cramer's rule? First of all, we have to write the matrix form. Matrix form is obtained by, first we have to write the coefficients of V1, V2 and V3 in a matrix form. So first column contains the coefficients of V1, and the second column contains the coefficients of V2. Third column contains the coefficients of V3. So we can write the matrix as 0.83 minus 0.5 0, 0.5 1.5 1 0, 0.7 minus 1, and the next matrix is V1, V2, V3, that is the unknown quantities, and that is equal to the unknown quantities to the so that is equal to 10 to 20. So this is the matrix form, and in that case V3, actually there is no need to find out all voltages V1, V2, V3 because we are asked to find out the current through 5 ohm resistor. Okay, in the question it is given that you are asked to determine the current in the 5 ohm resistor. So in order to find the current in 5 ohm resistor, we need only the voltage value V3. Okay, what is the current through the 5 ohm resistor in this figure? Current through 5 ohm resistor is V3 minus 10 divided by 5, right? So current in the 5 ohm resistor I5 equal to V3 minus 10 divided by 5. So we are in a need to find only the value of V3. So by Cramer's rule, we have to find out only the value of V3. No need to find V1 and V2 all. Okay. So it's a waste of time to find V1 and V2. So you can directly find out V3. How can you find out V3? For that, it is a ratio of two determinants, and denominator determinant is the determine the value of the quotient matrix, but numerator determinant is obtained by replacing the first column of the matrix with 10 to 20. Okay. Sorry, replacing the third column. It is V3, so we have to replace the third column of that matrix with 10 to 20. So it comes like this: determinant 0.83, 0.5, 10, minus 0.5, 1.5, 2, 0, 1, 20 divided by determinant of the quotient matrix. So we got the value minus 8.42 volt, and V3 is obtained. So I5 can be easily find out by the equation I5 equal to V3 minus 10 by 5. So we will get a minus 3.68 ampere. That means I3 is negative value. What is its meaning? Actually we have for analysis purpose we have taken I3 is flowing out of that node, and but we got the value of I3 is negative value. That means our assumed direction of current is not correct. So the actual current flows in an opposite direction that of the assumed direction. Okay, so that means I3 will flow into the node V3. Okay, that is its meaning. So that's all about this problem, and next we will meet with another problem. We will go for another problem, that is problem number 2, and its question is determine the power dissipated by 5 ohm resistor in the circuit shown in figure. So that is a circuit diagram. Look at the circuit diagram, and you are asked to find out the power dissipated by 5 ohm resistor. There is a 5 ohm resistor and a power dissipated in that resistor. You have to find it out. Okay, what will be the equation for power? You know that power is equal to voltage into current. Okay, V and I should be known for finding out the power, or voltage or resistance should be known. Okay, here resistance is known, so you have to find out the voltage at node 3. Okay, so that we are interested. That means determine the power dissipated by 5 ohm resistor. So look at the circuit diagram closely, and there will be 40 volt source, and there is a 3 ampere source, 5 ampere source, 6 ohm resistor, 3 ohm resistor, 4 ohm resistor, another 20 volt source, and 5 ohm resistor. And it is marked in the question that there are 3 nodes, 1, 2 and 3. So first of all, how can we start doing this problem? And since it's given and the nodes, we can go for a node analysis, and you know that between the nodes 2 and 3 there is a voltage source. So if you are going for a node analysis, it will not be very simple, so we have to do supernode analysis. Okay, so first of all we can apply node analysis for first node, since by using KCL at the node 1. Here is the node 1 diagram. The node 1 current voltage source 40 volt is connected, 3 ampere current source is connected, and 6 ohm battery and another 5 ampere current source is connected. So we can write the KCL as incoming sum of incoming currents is equal to sum of outgoing currents. And first of all we have to mark the currents, and except the all the currents are leaving out of node 1 except the current source, current from the current source. So the current directions are marked as shown like this. From that figure, 5 ampere and 3 ampere is coming to the node, so that means 8 ampere is coming to the node V1, and all other currents are going out of that node. So we can write the equation of KCL as, first of all, V1 minus 40 minus V3 divided by 4 plus V1 minus V2 by 6 equal to 3 plus 5. You can see, first of all, it is somewhat difficult to draw the node 1, because you can see from the, you can compare the circuit diagram given in the question and the node 1 diagram. See, in the node 1, 40 volt battery is connected to, one end is connected to node 1 and other end is connected to 4 ohm resistor, okay, and but that 4 ohm resistor then connected to node 3. So V3 will be there at one terminal of 4 ohm. And similarly, when we are drawing 6 ohm resistor is, one end is connected to node 1 and other end is connected to node 2. So there will be V1 and V2 for 6 ohm resistor, and if 5 ampere is connected to node 1 and node 2, and since it is a current source, there is no meaning of accounting V1 and V2. And this is all about node 1. So in the previous questions, we can directly draw the one terminal is a reference node, so we can ground that node. But here it is not correct, because 40 volt battery is connected to 4 ohm and 4 ohm is not connected to ground potential. It is connected to node 3. So we have to mark V3. Okay. So when we are writing the equation for node 1, its equation will be, first of all, we will consider the branch containing 4 ohm resistor, and its current through that 4 ohm will be equal to V1 minus 40 minus V3 divided by 4 plus next is 6 ohm, V1 minus V2 by 6 will be equal to 3 plus 5. So we will get the equations as 0.42 V1 minus 0.16 V2 minus 0.25 V3 equal to 8. And I am not describing each and every step. It's simple mathematics, and you can write it in your notebook. Okay, this is the final equation we got from node 1, and that is equation number 1. And next is equation we are considering the node 2. You can see node 2, we cannot simply consider node 2, because there is voltage source 20 volt connected to node 2 and also node 3. So we have to consider the super node between 2 and 3. So we have to draw the super node in the next diagram. So the super node will be like this. That is, there is node 2 and node 3. We are neglecting the voltage source 20 volt, and at node 2, what are the components connected? 5 ampere voltage current source is connected, and 6 ohm battery, 6 ohm resistor is connecting, 3 ohm resistor is also connecting, and at the node 3, 5 ohm is connecting and 4 ohm is connecting, also 40 volt. And here we have to notice that 5 ampere from the question, 5 ampere is current source is connected to node 2. 6 ohm resistor is connected to node 2. And both of these components, other ends are connected to node 1. So V1 will be the voltage, node voltage in the case of 6 ohm and 5 ampere current source. And also 3 ohm resistor is connected to ground potential, that is connected to ground. So 3 ohm can be connected like a ground. And next, when we are considering third node, and 5 ohm resistor is connected to third node, and it is its one end is connected to 5 ohm resistors, one end is connected to ground potential, and also at node 3, 4 ohm resistor is connected, but its other end is not connected to ground point, it is connected to 40 volt battery. Okay, and then it is connected to V1, node V1. Okay, so we can draw the super node like this. Okay, that is explanation for this super node diagram. Okay, you should clearly understand it. And next we can write the super node equations as starting from the node 2, we can write it as V2 minus V1 divided by 6 plus 5 ampere plus V2 by 3 plus Next is we are connecting third node, that is V3 by 5 plus V3 minus minus 40 minus V1 divided by 4 equal to 0. Here there is a little bit confusion for you. First of all, we can discuss by each branch. For the node V2, first we are considering with a 6 ohm resistor. When we are considering 6 ohm resistor, you can see the current through 6 ohm will be V2 minus V1 by 6. There will be no confusion, okay? And next is the 5 ampere current source. And the current itself is given, so it is plus 5. And next is 3 ohm resistor. So the current through 3 ohm is equal to V2 by 3. And next we are coming to the third node, and in that case the current through the 5 ohm resistor will be equal to V3 by 5, and current through the 4 ohm resistor will be equal to V3 minus 40 minus V1. Why it is V3 minus 40? If it is connected to in a manner, plus is connected to 4 ohm and minus is connected to other terminal, then it will be V3 minus 40. But it is given that the one end of 4 ohm resistor is connected to negative terminal of 40 volt battery. That means there will be a negative voltage. So the current through the 4 ohm resistor will be V3 minus 40 minus V1. But you know that I have given it in this V3 minus 40 minus V1. But V3 minus 40 means it will be V3 plus 40. So it is given that V3 plus 40 minus V1 divided by 4 equal to 0. I think you got the idea. Because 40 volt battery is connected in a manner that its negative terminal is connected to 4 ohm resistor. So we have to write it as V3 plus 40. Okay. So V3 plus 40 minus V1 divided by 4 equal to 0. That is equation for supernode, and we can rearrange the terms, and we will get the equation minus 0.42 V1 plus 0.5 V2 plus 0.45 V3 is equal to minus 15. That is second equation. So we got 3 variables and 2 equations. So in order to solve this equation, we need one more equation. How will we get other equation? From the question, we know that up to this point we are not considering this 20 volt battery connected between node 2 and node 3. So we have to consider that voltage also, and we know that its voltage value will be equal to V2 minus V3 equal to minus 20 volt. Okay, you know that minus 20 volt battery is connected between node 2 and 3. So we can write that V2 minus V3 equal to minus 20 volt. Okay, so we got the idea is equal to V2 minus V3 equal to minus 20 volt. That is equal to third equation. And why minus 20 sign comes? Because if we are starting from the point in node 2 to node 3, we are going from left to right. First terminal connected to node 2 is negative, so its value will be negative 20 volt. So V2 minus V3 will be equal to minus 20 volt. Okay, that is explanation for minus 20. And so we have got 3 equations, equation 1, 2 and 3, and 3 equations and 3 variables are there, and we can simply apply Cramer's rule to get the unknown variables. So for applying Cramer's rule, first of all we have to write the matrix form, and the matrix form contains the quotient matrix. So the quotient matrix is obtained by writing the quotients of V1 in one column, and V2 in the second column, and V3 in the third column. Next V1, V2, V3 will be another matrix, and equal to 8, minus 15, 20. Okay. And next for applying Cramer's rule, we are asked to find out what we are asked to find. We are asked to find out the power dissipated by the 5 ohm resistor. So power will be equal to voltage power will be equal to voltage into current, or V square by R, or I square into R. So once we got the value of V3, we can easily find out the power. So there is no need to find out each and every voltages. We need to find only one voltage V3 in order to find out the power dissipated by 5 ohm resistor. So V3 is obtained by replacing the third column of the quotient matrix by 8 minus 15 minus 20. So we got V3 like this, and V3 will be equal to 18.11 volt. So power dissipated by the 5 ohm resistor is P5 ohm is equal to V3 square by 5 ohm. So simply substituting the value of V3, we will get the power dissipated by the 5 ohm resistor as 65.59 watt. Okay, that's all about today's topic. So we have discussed about node analysis and supernode analysis. And we have done 2 problems from each topic. So I think the idea should be clear to you, and I think you can solve the problems yourself. Okay.